Is the question. The beam shown in the figure P1.27 has been stiffened by the addition of a spring support. So you see, a spring, uh, it is mounted over here. So it could be a steel structure because steel column acts like a spring. So it is not necessary that it's a coil spring. So you may have to understand that intuitively it can be a steel column which has its own stiffness. And it is asked in this question, the steel beam, this beam is a steel beam, okay, and it has some length. So the length is, I would say, length is fine at this, and the thickness. So this thickness, okay, this is thickness, okay, this is thickness of the beam, which is 0.03. So, and then it has the width, which is over here. So if you take a look, this is the width inside the paper. This is a little bit tough for me to draw a straight line, but you understand that. So this is the width. This width is 0.3 meters. Okay, let me draw the section outside here. So if I take this section here, so this is the width, this is the thickness, and this thickness is 0.03. Okay, now it is asking you that the steel, and the length is given. Length is how much? 0.91. The thickness and the mass, which is the mass of the beam is given. This is the mass, which is 55 kilogram, and the mass on the top of it, which is, other than this, is the mass of the beam. The mass on top of it, which is 580 kilogram. Let me complete the statement here. Still it is incomplete. What are they asking? So neglecting the mass of beam. So he's telling us, do not include the mass of the beam. Compute the spring constant K necessary to reduce the static deflection to 1/2 to its original value before the spring was added. So what happens, that let me show you. So he's trying to explain that if there is no structure, there is no external spring, so it will deflect like this, okay. But now when you add this spring, this deflection, suppose this is x. So originally it was x, but after adding the spring, this spring, after adding this column, the deflection is 1/2. It is what it is saying, that by adding that spring, which is a steel, maybe a steel column, to reduce the static deflection to 1/2 its original value. Have you guys understood this problem? Right? So we have to add this column, steel column, in the middle of that beam, such that the deflection of the total beam is reduced to 1/2. Okay, now he is saying ignore the mass. So now in this table we do not see such a simply supported beam stiffness given, but that's why I'm giving you this information, that this for a simply supported beam, the the stiffness of the beam is 4e wh cube over l cube. I will add one more table, probably not now. So this is how the formula looks like. You don't have to derive it, but it will be, if I give you this question, so it will be it should be there. Or if you have the book open, it is convenient for you, you should mark the table. I would advise you guys mark the table when you are taking the quiz or test, so it's easy to go to the tables to see what structure we are looking at. Okay, now let's see, this kb is the stiffness of the beam which is simply supported at both ends. So now, if you do me a favor, I just write down the values, open your calculators. This is a steel beam. Okay, this is steel. It is written, the steel has Young's modulus 200 gigapascal. Okay, and the width of the beam is how much? It is 0.3 meters. Agreed. And the thickness of the beam is 0.03 power 3.03 divided by the length of the beam, which is 0.91 power 3. Please open the calculator and tell me what is the answer, and then I will move forward what to do next. Okay, the online students can also do the calculations and write down the answer in the chat box. To the power 7 or 6? 6, that's correct. Newton per meter is the stiffness. Now after you find this, now you have to make a combination. You will tell me whether this beam and this steel column, are they combined serially or parallelly. If you understand that thing, then it should be easy. Okay, so they, what do you suggest? So this is a stiffness, this is stiffness of the beam. So this is the grounded ends, so they are combined in, there are springs in the parallel combination. Why is it parallel? Look, this is like a spring over here. Okay, and this has the deflection, I would say it should be, so let me write down here. I would say this is the beam spring. Okay, and this is the column stiffness, because the deflection, you see, but the main idea is the deflection should be the same in parallel combination. So if the beam deflects x distance downward, the same deflection happens for this column x distance downward. You understand me? So they are combined parallelly, so keep in mind that difference. So the k equivalent, it is kb plus k. Now if you take a look, what is the formula? Let me show you the formula for the spring. Formula for the spring, it is kx. So if the beam has a deflection, before you attach the column, this x is the deflection. After you attach the column, like equivalent k, I would say force is the same. Okay, force is the same, I will say. So force is the, now the new stiffness has been added. So deflection is now x by 2. because our objective is to reduce the beam deflection to 1/2. Agreed? With the same amount of force. So this equation and this equation, you will just equate them. Okay, once you equate them, so what will happen? K x over 2, k equivalent x over 2 is on the right hand side. So let me write, you can write in the right one. So this x is cancelled by this x. So what is k? K equivalent should be equal to 2k. Okay, 2k. How would you get 2k? Look over here, 2k means 2k beam. I would say this is kb because this is for the beam. Okay, 2k for your more for convenience, this should be 2kb. And this is suppose equation number 3. Can you compare equation number okay, this one is also equation number just 4. Compare this, k equivalent is equal to 2kb. So I can write down 3 and 4, they are equals. So k equivalent is equal to 2kb equals to what? Equals to kb plus k, kb plus k. So what is k from this combination? If you just do the sum rearrangement, k equals to kb. Agreed? So this is how you will, so the stiffness of this column should be equal to the stiffness of the beam in order to reduce to 1/2 of the net deflection. Correct? You understand me? So this is how you will solve this. The problem is solved. This was asked that how much should be the stiffness of the column such that the deflection of the beam should be 1/2 of the region. Okay, this is how you will solve it. Have you understood this problem? Yes? That's good. So let me